Okay, so when I project the notes, I won't be able to see the chat, so you're just going to have to speak. I'll learn your names eventually, but just say your name before you speak. It's Sergio, Fabian, Lucero, and somebody just left. I'm not sure who it was. I can't remember. Oh, Ivanel. And okay, so let me make this bigger. So first of all, what did you think of the videos? Comments, impressions? Did you like them?
The
They were.
videos were, I'm sorry.
Nah, sorry, you first.
Pueden hablar español. It's okay. Mhm.
The videos were like easy to follow, and the examples were very simple.
Good. And practical? Yeah, really live. Sergio?
Yeah, I was kind of gonna say the same thing. I was gonna say, they were pretty entertaining.
Good, good. The only distraction is that they were older, right? It was almost 30 years ago. Is it 30?
Yeah, but it was cool.
But it was cool. I think that is the best presentation I've ever seen of those topics that tie comfortably with my materials. And it's just been that way, and it's still the same. There's still those agencies still exist in the federal government. They're still doing the same thing. They still have the same issues, the same problems, and they're all practical problems. Okay. So most my notes, like 70% of my notes relate directly to the videos. And then the other 30% are other things I've put in there and some background that you might not have gathered from the videos. So Claudia's here. Claudia's the one, she asked me for the Spanish notes. So I send them to everybody now, okay? So you could follow along with both or just stick with whatever you feel comfortable. I'm going to display the English notes. So you can see them, right? No, you can't see them, can you? I have to share first. You guys didn't say anything, but you didn't see them, right? I have to share my desktop. And then now,
Yeah.
right? Okay, so you see them. And do you see yourselves too on the screen?
No.
Oh, just my notes. Okay. So if you're going to speak up, just say your name and speak. So we looked at this last class. We talked about what a statistic is. We talked about different types of data that are variables, so identifying exactly what we're interested in, the characteristic of a person, place, or thing that we're interested in is known as a variable. Then we define two kinds of variables, two main types, and then two subtypes of variables. And we discuss the differences between quantitative and categorical. And then within categorical, there were two different kinds. And within quantitative, there were two different kinds. And within categorical, there were two different kinds. And it was pretty straightforward, right? Pretty straightforward. And then I gave you some problems here. Who had a chance to do these problems? No one? Do you want to work on it together now? You have to tell me because I can't see you.
Yes.
Okay, so why don't you try this? I give you 5 minutes. Well, yeah, like 5 minutes. Try and identify for each one the type of variable, and then the subtype. So if it's quantitative, so for the first example, is this quantitative or categorical? Height of women 18 and over. And what I've done is I've made a column here for kind of values. So you can measure women, or you can measure heights in feet or in inches or centimeters, right? So let's say you said 5 feet, 5 inches, sorry. 5 feet, 5 inches, or 165 inches. Something like that. Those would be the kind of values you would see. Is that quantitative or is it categorical?
Quantitative.
It's clearly quantitative because you can measure it with a stick. You can measure it with a tape. You can measure it. And if you measure it and Sergio measures it, you're going to get the same measure, even if you have a different measuring tape, right? Different people, different tape. It's objective. So this is quantitative. And now you have to go back, and there's 2 types of quantitative that we discussed. One is discrete and one is continuous. What kind of variable is this quantitative variable?
Continuous.
Okay, why is it continuous?
Because it includes fractions.
Right. So it includes fractions or portions of a measure, not whole numbers. Discrete indicates that it has to be a whole number. 1, 2, 3, 0, 1, 2, 3, like that. Okay, very good. Okay, do the rest. Give you some time. I'll give you 5 minutes. So I'm recording this video and I will put it up on the platform. I will put it in YouTube and link it on the platform. How's it going? Are you finished? Do you need more time? Okay, so let's try this one. Sergio, tell me about this one, number 2.
Okay.
Uh-huh.
Number 2, I got quantitative and discrete.
Perfect. So this is quantitative because it's objective, how many hours, if you're counting hours or if Ivanel is counting hours, you're going to count the same way. So it's objective. And because it says specifies whole, it means it's discrete, no fractions of an hour. And again, you don't have to put anything here. This is if you're a little bit confused or if you're trying to defend your answer, you can put here examples. Okay, you're going to see what I mean in the next and some of the other problems. Okay, very good, Sergio. What about Fabian? Can you do number 3 for me? A little more challenging.
I put quantitative and discrete.
Okay. What was your example for?
Says place of runners was like second, third.
Okay, let me expand because
This place.
so your example is that the values would be first, second, third, right?
Yeah.
Like that. Okay, and it's discrete because you can't have the 1.5 place. It's just 1, 2, 3, etc. Where
Yeah.
first is the best. Does anybody have a problem with that?
I thought I was qualitative and ordinal because with ordinal the rank is important.
Okay, so, but why did you make it categorical or qualitative? Why did you choose that?
I just me dejé llevar por lo de ordinal, lo del orden, like the
Right.
order is important. So
Okay,
I just assumed it was
yeah, no,
qualitative.
I tend to go, this is, I'm talking to, sorry, su nombre, a Lucero, right?
Sí.
Lucero. Okay, so I tend to agree with you. And the reason is this, if you think about the place of runners in a race, think about like in a field, track and field, they have many heats, right? And if you run first place in one heat and somebody else gets first place in another heat, it's more like a category because it's not exactly, it can be different number. Like in one race, let's say in one heat, all the people can be really fast. And in the second heat, the second group running, they could be really slow, but somebody still gets first in the first one and another person gets first in the second one. They end up all first place, but they could have different numbers, different values. It's not really like it's less likely to be quantitative. Quantitative would be if you're looking at the time, right? The time, the speed, or the time that they take to run 50 meters or 100 meters or 5,000 meters. Okay. So I tend to think of this as, but I mean, you could argue for this. The problem I have, like I said, is that it is from from place of runners, it changes from heat to heat. It's not going to be the same with different groups. It's kind of like they fall into categories. So I prefer the answer categorical or qualitative. And like Lucero said, it's going to be ordinal because the order matters. What's another reason to explain that it's not quantitative? Well, that's my best explanation. So anyway, think about this a little bit. We're going to try down here, number 6, similarly. So number 4, let's go to number 4. Do you like multiple choice questions? That's the variable. The values of this variable, this is the question. The variable, sorry, is going to be the answer to the question, right? The response to the question, do you like multiple choice questions? So over here, I'm going to write down possible responses. Could be yes, I like them. No, I don't like them. No comment. Things like that. Okay, so those are the values. And then because the values have to be numbers in my coding, I can recode yes as 1, no as 0, no comment as 2, something like that, right? Usually in surveys, there's a code for no response. If some people don't respond. And you can code that as, sometimes they don't code it as like 3, they'd code it as some other number just to, it's just a habit they have to make it very distinct from the other numbers. Wait, put it here. So this is the kind of data that you would get out of a question like this. So what kind of variable is that?
Is categorical. And the other one is nominal.
Okay. So why is it categorical and why is it nominal?
Because I'm giving the number to the answer.
Right. So
Uh,
yeah. So the numbers assigned are assigned by Lucero as 1, 0, 2, 3, but it wouldn't be wrong if Claudia was doing a similar study and she made this 0, this one 1, this one 2, and this one like 99. The number doesn't mean anything except for the category. That's why it's categorical, and that it doesn't mean anything specific, and the order doesn't mean anything specific makes it nominal. So the order doesn't matter. Questions? So this reality that you have different kinds of variables and subtypes of those types of variables, very important for statistical analysis. You need to know what kind of variable you're dealing with to do the right, to perform the right calculations. All right, so this is a first step, identifying what kind of variable you have. Okay, next one, number 5. Did I have anyone else say something already? Sorry. Claudia, let's do Claudia. Score on a test, what do you get?
Is quantitative and continuous.
Okay, good. Quantitative. And continuous. Now, you were assuming that the results are like 85.5%, right? Or like 49%. That's kind of what you're assuming, that it's a value that's, you're assuming that it's a continuous quantitative value. But what if the results are, I'll do a different color. What if the results are A, B, C. What would you call it then? Now, maybe the word score for you should be a number and you're just going to go with this one. But let's say it was like, you know, your score was then put into a letter score or letter grade. What would you call this kind of grade?
Categorical.
Very good. And
Nominal.
does the order matter? Do you like an A better than a B?
Oh, well, sorry. No, the order does not matter, I think.
Well, do you prefer an A or do you prefer a C?
I mean, I prefer an A,
So
but
the order matters. Okay, that's how you figure it out. Is there a difference? Does it impact you different? Yes. So ordinal.
okay.
Yeah. I think maybe you're thinking it's nominal because it could be subjective assigning the grade. But what I'm looking at is the letter itself, the order of the letters. Is it meaningful? Is there a scale? Is one better than the other? Yes. So it's ordinal. Okay, so I'm just showing you that it's not as straightforward. You know, it's not hard. This is not hard, but we're basically raising all the contentious issues by evaluating the variables like this, okay? All right, number 6. Who have I not asked to speak up? I think everyone's spoken, right? So anyone tell me, what about 6? What do you think, given what we've already discussed?
Categorical and ordinal.
Excellent, Claudia?
Uh-huh.
Perfect, yeah. You get the point, right? This is categorical. Because you don't have a scale, you don't have a measuring stick, you don't have, maybe you have an algorithm, to determine who's the best salesperson. Now, if you're going to assign the best salesperson as the one with the most sales, then that's pretty clear that you can make that quantitative. So if it's just based on sales, but that's not necessarily true because in a performance evaluation, they consider your years working, they consider the number of contacts, they consider your team, you know, your contribution, your productivity, but more than that in a performance evaluation. So usually we'd see this as categorical because they're going to say first, second, third, right? It's going to be like the race. And order matters. Certainly, I want to be first or closer to the first than last. So order matters. But there's no measuring tool that's going to give me, well, unless, again, you have an algorithm and they've specified all the parameters and you found all the values and put them in, but that's not what this says. It's a performance evaluation and it gets ranked. You could have many, you can have a manager ranking you. You can have a team of managers evaluating you. And that's relatively subjective. And then you get ranked. But if it was just based on your total sales, that could be quantitative. Just like I was talking about runners in a race, if it was just based on your speed, that could be quantitative. But you wouldn't be using first. The point is the value. First, second, and third, what can I do with those numbers? The fact is that adding those numbers together, taking an average of those numbers doesn't have so much meaning. And I'll show you in the next example how that might be. Any questions about this? The answers are actually, the suggested answers are here on the next page. And I did put categorical and ordinal, yeah. So this is my substitution for my messy writing. Okay, so they're right there on the next page. Okay, what I want you to do is try this quiz. Did you try this one? In this quiz, for each variable, tell me which one is quantitative, categorical. If it's quantitative, if it's discrete or continuous, if it's categorical, is it nominal or ordinal? So I'll give you 5 minutes. Okay, how's it going? Ready?
Yes.
Okay. So who wants the first one?
I put down that the faculty is gonna be categorical, and since I'm the one assigning the value to the faculty is nominal.
So perfect. It's categorical and nominal because the number that's associated with each value could be different depending on the researcher. These are in alphabetical order. In alphabetical order, I could assign art to 1. I could code continuing education as 2, human ecology as 3, and so on. And just make other 5. And that's my numbering scheme. The numbers don't mean it's not that continuing education is better than art or anything like that. They're just asking which faculty. They're not asking you your favorite faculty. It's not a scale. It's not a scale of preference or anything like that. Another researcher could assign according to the numbers, according to the largest faculty. Maybe continuing education has the most, and science has a second, and then human ecology has that, and the 4th is other, and art is the 5th that has the least. So the numbering scheme is subjective. That's why it's nominal. Any questions about that one? Number 2, on average, how many glasses of milk do you consume per week? Sergio, what did you put there?
I put there quantitative and discrete.
Okay, good.
Oh, all right.
The quantitative discrete is a good answer. People will say, what, 0 glasses, 1 glass, 3 glasses. Some people want to say 1.5. It depends how you're collecting the data. You can make a survey online where people can only enter whole numbers, but it doesn't specify here. So if somebody said quantitative continuous, I would accept that as an answer too. Okay, it depends. In this case, if you overlooked being specific to add a word like whole, complete glasses of milk, if you missed that word, then you could get responses that are fractions. Or if you didn't restrict the entry of a fraction or a decimal value, you'd have to make it continuous. Okay, and again, that's important because it changes the way you analyze the data. These are very similar, I have to admit, but it's even more specific. It's continuous, but there are no negatives, right? Sometimes when we say continuous, it could be negative or positive, but this is continuous, but it's always positive. That's why maybe you'll lean towards discrete, because at least those are all positive values. You're counting values. You don't count negative. So depending on your data, you would assign the name. Like like I said, again, if you overlook putting whole milk, you might get a mixed bag of results. And then you could, given what the data shows, it'd be one or the other. Okay. All right. Number 3, Claudia, what did you put here? Number 3.
I think it's qualitative and nominal.
Okay. So qualitative or categorical? And she said nominal. Did anybody have a different answer?
I put down ordinal because
Ordinal.
it's talking how dark is the hair.
What did you,
Mhm.
Claudia, you agree? Do you agree, Claudia?
I don't know.
Well, the question is how dark. So it's categorical for sure. Because if I want to make black the number, so there's 6 options. If I want to make black 7, sorry, 6, or if I want to make it 1 is up to me. So that makes it categorical for sure. The number doesn't mean anything. And but the order does, because it says how dark. If I said the numbers are 1, 2, 3, 4, 5, 6, which number is more dark?
Okay.
So you're going to pick 1. It's just like when I asked, which grade do you want? Do you want an A or you want a C? As soon as you answer that you have preference or one is better than the other or higher than the other, then you know it's ordinal. So this was tricky. I'll give you that. This is the tricky one. Okay. But it's because of that word, it becomes ordinal. Now, if you analyze it as nominal, that would be okay. However, you would be missing this extra information that could provide you opportunity for more sophisticated statistics. Okay. Again, we're not going to analyze more sophisticated statistics in this class, but it's important that you know the difference between nominal and ordinal. Ordinal, you can actually do regressions with and make predictions of. And I'll explain what that all means later too. Very good. Thank you, Claudia. I gave you the hard one. Well, the next 2 are also a little challenging. Who did I not? Fabian. What did you pick for this one?
I think it's categorical. There's no like measurement. It says how often. Ordinal.
Excellent. Okay, so this is really important because many surveys have questions like this. If you've ever answered a survey online, has everybody here answered a survey in their life? No? You never answered a survey before? You've never seen a survey? So surveys are often like this. And the reason they do this is because they just want to see a pattern, They don't need exactly the value, and they want to encourage people to answer the questions. So people might have a rough idea how much they exercise, but they want to capture, because some people, if the question is too specific, they might think about it too long and then just get exhausted and just skip it. Like they won't even give you the information. So this way it encourages them, just if they don't really exercise, that's what you want to capture. Look at here. The second one is once or twice. So there's actually 2 numbers in this category. That's how you know it's a category. It's not a specific number. It's a bunch of numbers in one slot or one category. So that's how you know it's categorical. And this one has a whole bunch of numbers, more than twice. If you're going to say this is like, some people exercise twice a day. Some people, so the most somebody could exercise would be, well, if you want to say how many days do you exercise, it's up to 7. So more than twice could be 2, 3, 4, 5, 6, 7. But some people could try exercise more than once a day, and that could even be higher. So this is a whole host of numbers in one category. So that's why it's categorical. And you'd like to say you exercise more than twice, right? This is a higher number. It may be even a more preferred number. So that's why we say it's ordinal. There's a difference. The problem with trying to calculate averages or basic statistics with this is that, let's say the data look like this. Let's say this was my data in Excel. So I say I have a headline exercise. And then I assign numbers 1, 2, 3. And let's say the person, the first one, so I would put an ID here variable. So the first 1, 2, 3, 4, 5, just giving you an example. And let's say there's some more data there. So the first person says they exercise 0 times. And the second person says they exercise 0 times. And the third person says they exercise 10 times. And the fourth person says they exercise 15 times. And then the fifth person says they exercise 0 times. What is the average? So we're going to code this with, because the data doesn't, it's not going to be this. We have to code. So we're going to make a variable called X code. So we recode the data using our numbers here, 1, 2, 3. And what do we get? This one is 1. Let me clean this a bit. So this one is 1. This one is 1. What is 10 going to get? 3. What is 15 going to get? 3. And what is 5 going to get? 1. These are the ones you would have to average. Let's say this was all the data we had. What would the average be?
Nine.
Okay, so let's get the average of this. How do we calculate an average? We add them together. So the average is going to be 1 plus 1 plus 3 plus 3 plus 1. Divide by 5. What do you get?
$1.8. Fracciones.
So it's going to be 1.8. So you're, first of all, yes, you're going to get a decimal. It's not going to be one of the numbers. Maybe you can round up. Now you have to ask yourself, is that meaningful? Nobody was 2. Nobody was once or twice. Either they exercise a lot or they didn't exercise at all. This number doesn't reflect that at all. So you wouldn't want to average this data. The best way to represent this data is to make a chart and show that most people are either in this category or this category. Okay? The problem is that these are very high numbers and they're distorting the data, and that 2 doesn't really reflect that anybody's here. So the average person is not once or twice. Okay, so that's why with categorical data, we don't do this very often. We have to be careful about doing things like that. Instead, we can make a bar chart and we can say, how do you put here the variable, how often, exercise, and then we're going to say less than once. You can even put the words in there. Or you can just put the code, right? So the code is 1. Well, no, that'll throw people off if they saw the chart. Let me make this. Oh, I'm going to do it like this. Less than once. 1 or 2. And then more than 2. Like that. Is everybody okay with my symbols? And then basically you're going to have 3 data here. 1, 2, 3. And you're going to have 2 data here. And that is how you report the data. Are you guys following my logic? So it's really important that you know this issue. Having said that, we can attempt to do some more sophisticated stuff, but we're not going to do it in the class. Okay, with that in mind, that was Fabian talking to me. So what do you think about this one? Who else? Ivanel?
Quantitative indiscrete.
Okay, so you want to say it's quantitative and
Discrete.
okay, quantitative discrete. What did other people think about that one? Thank you.
Wouldn't it be the same as number 4?
Lucero is saying it should be the same as this one. What do you think, Ivanel? So let's use the same logic. Let's go through each category. Under 25,000, many numbers can fall under 25,000 from 0 to 24,999. So it's really not quantitative. It's actually a category where many numbers can rest. Now, it's very tricky because you have, when you think income, you think quantitative, but this variable has been it's been put into categories. And again, the reason is to encourage people to answer the question. Most people are very private about their income. They don't like to reveal the information. So it's better to create categories where they can identify themselves. I'm under here. So, you know, you don't look poor. If you're making $10,000 a year, you fall in this category. So it encourages people to say, okay, I'm in the first category. The second one, again, has many different income earners values in here. So it's not just quantitative. It's not a single value. It's a group of values or category of values. And then the third one is the same. So this one is tricky, Ivanel, but it's the same as number 4. So this, again, you can code 1, 2, 3. And because 3 is higher income or better than 1, it's ordinal. So it's not going to be quantitative and discrete. It's going to be the same as number 4. So this was definitely tricky. This one was definitely tricky. So I give you that. I can't fit it in. I'm going to make this one smaller. You guys can take a screenshot if you want, but again, I'm going to have the video for you to see. Questions? Okay. All right, so let's so I'm gonna continue and then we can take a break at 7:30, okay? All right, let me get out of here for a moment. Okay. You can see each other. So there's some pages to read there. There's a page about different types of variables in a different kind of hierarchy. Ratio, interval, ordinal, nominal. That's other terminology. You can look at that. I'm not going to test you on that, but it's important that you understand the different kind of terminology for variables. Do you have any questions for me? I'm just preparing my slides. Have any of you been part of an experiment that you know of? I mean, you should know that you're part of an experiment, but anyone here been a part of a trial or experiment in the past? Nope. I participated in one time. So that's what we're going to talk about next, about experiments. First, we're going to talk a little bit about the video and the difference between surveys and experimental design. Okay. Well, that didn't work. All right, so you're introduced to experimentation and to other kinds of studies that collect data. Okay, so experiments collect data, and so do observational studies. What's the difference between experiments and observational studies? The main difference.
Experiment, you can control one of the variables.
Okay, what you're getting at is that okay, so it's close what you're saying, but the idea is that I will impose a treatment or I will impose something while controlling all possible variables. I'm going to impose a treatment to see the response. So the goal is to try and control variables. You're not just controlling one, but you want to try and control all of them so that if there's some sort of notable effect, you can attribute the effect to the treatment or the, we call it a treatment, but to the variable or the factor that was imposed on the subjects of the experiment. In observational studies, you don't try and change anything. You're looking for changes. I mean, they talked about longitudinal studies or perspective studies where they follow people or objects for a period of time, over years. In that case, you're observing and you're looking for any changes, but you're not trying to cause a change. Okay, so observational studies. Okay, well, I say what they are, but observational studies don't otherwise impose or attempt to influence a response in the study subjects. If it's people, or if it's even you're observing, and the example was with the lobster in a tank. Do you remember the lobster study? So a woman was, researchers was just observing the lobster, wasn't doing anything, just recording its behavior. And then what they saw made them wonder, well, if we blur the vision of the lobster, how will it behave? So in that case, they imposed a treatment. They imposed an ink to blur the vision of the lobster to see if its behavior changed. So it went from an observational study to an experiment at that point. An experiment deliberately imposes some treatment on individuals or subjects in objects in order to observe their response. So yeah, it could be people, it could be things. So I asked you here to identify scenarios in the video, just so you remember the video. That will bring these, that will make them your understanding of these concepts, or it will help you remember these concepts better by having a visual cue. So what is an example, other than the lobster, of an experiment in the video?
El de los cigarrillos fue un estudio de
Okay, so
perspectiva.
smoking. So the experiment was to see, in the experiment, sorry, in the cigarettes causing cancer experiments, they used tar on rats or rodents, like hamsters. Oh, my writing is so messy. I gotta fix that. Okay, so was a cancer a response to adding tar on rodents? So that's an example. Anyone have another example they want to mention of an experiment? Also, they had the rodents actually inhaling smoke, right? Tar or smoke exposure. That's an E. And anybody else? Any other experiments?
The
No?
one about the heart attack.
Right. So the other one was physician health study. With aspirin, right?
Yes.
So that would be like the second, this was like the first. Okay. Okay, so those were experiments in the video. What about observational studies? What are examples of observational studies in the videos that you saw?
El de la aspirina.
Well, the aspirin was actually an experiment,
Ah, pues,
right?
sí, sí, sí,
Because
el-
they
el-
actually
ejemplo.
gave them aspirin to some and they didn't give aspirin to the others, and they saw what was the impact of giving actual aspirin.
Sí.
That was an experiment, so thank you for the clarification. What was an observational study? Again, they're just observing. No? You don't remember?
It was about the elections.
The election. The election was. That was a poll. Yeah, you could say that was sort of observational. They didn't impose anything. They didn't go around. You know, the idea of giving a poll and collecting information from a poll of people's opinions, that could be an observational study, sure. That's not an experiment, right? So an example could be an election poll. So they did a poll for the president. Who are people going to vote for? What about all those surveys? Those were observational studies. And the census of the homeless, that's an observational study, okay? So the census of the homeless. And NORC surveys. NORC surveys that they conducted. Wow, I can't remember the acronym stands for. Let me see. NORC. Most of these are part of the Census Bureau. They use them for employment surveys. NORC. I guess they might call it something else now. They have call centers that they do interviews. They don't necessarily go to people homes anymore, like they were showing in the video. Have many ways to reach people. So funny. Let me see. All right, so any other examples of observational studies? No comments? So when they were asking people, how many times a week do you work? How many hours? All that. Those were employment surveys that were conducted by the NRRC. Okay, there are two types of observational studies mentioned in this video. One type of study uses data from the past, while another type of study follows subjects for a number of years from the start of the study. What are the different terminologies? No, you don't remember? Are you guys telling me you didn't watch the videos? Indirectly telling me? Maybe you missed this part or you didn't write it down. But if you watch the video after reviewing the notes a bit, you would have noticed this. A retrospective study uses data from the past, so it looks back, retrospect. And a prospective study follows subjects for a number of years. Okay. All right, let's talk a little bit about experiments. A little bit more about experiments. So in human trials, it's necessary because of years of observation. When humans are engaged or involved in an experiment, there's evidence that they might change their behavior simply because they're part of an experiment. They might change their behavior, or their beliefs about participating in the experiment might affect their biochemistry and may affect their outcomes. So what happens is, in experiments of human subjects, we impose a control group. The idea of the control group, and we're going to review the physician health study to talk about it more carefully, is to control against both the placebo effect and the Hawthorne effect. The placebo effect is where simply being in an experiment may, so let's speak about medical experiments. So let's say you've been admitted to an experiment for a new treatment because you've been suffering pain for a long time. And as a sufferer of pain, you're very optimistic to be taking part in a study. And that optimism, that positivity may release endorphins in your body and just make you feel better as a result. You know what endorphins are? There's like these feel-good chemicals that help in the body, just a more positive, uplifting feeling, and can actually reduce sensation of pain. So you want to control against that, being that between that happening. You don't want to stop that from happening. It's okay. But what you want to do is you want to measure the impact of the treatment. So you need to guard against collecting information that's just a result of endorphins or this placebo effect. Another thing that might happen is that human subjects being part of an experiment might change their behavior. So let's say there's an experiment for a new type of weight loss drug, and people involved in the experiment might become, because they're being observed by medical staff very closely, they have to go in repeatedly for to collect data. They got to get measured. Their waist is measured, or their hips are measured to see the inches of weight loss that they experience, or the inches of fat loss that they experience. And also there'll be weight on a scale. So this fact that they're going to be observed might inspire them to exercise more, eat better, because they're being observed. On the other hand, some people might, even though they've agreed to participate in an experiment, may be more rebellious and not do those things. I don't want to measure that change in behavior and the impact of that change in behavior, I want to remove that and be able to see the effect of the actual pill for weight loss. So how will I deal with the fact that people are changing their behavior or their mental state changes that's going to affect their response? So what we do is we create a group called the treatment group and a control group, different from the treatment group. And how is it different? They are the people in the treatment group get treated exactly the same way as the people in the control group. But the difference is that the people in the control group aren't really getting the treatment. So if it's a pain medication, they're getting medication that looks exactly like the real, they get a pill that looks exactly like the real medication, but otherwise there's nothing in it. So it's just either cornstarch or it's just baking soda. It's nothing that's going to change their biochemistry to make them feel better. So they're not actually getting anything that has a medicinal property. The treatment group is actually getting the drug. The trick is that neither of them nor the researchers that are directly in contact with them know which one they got. So they don't change. They're not treating the patients any differently. So what you get out of that is there's a long discussion too about how they get assigned to the treatment group. So this is the treatment group. I'll make this pretty simple here. Let's see. So this is going to be my bar chart of this is the treatment group. And this is the control group. And this is the percentage of people that improve, whether they on a survey, they actually say they feel less pain than they felt at the beginning of the study. And in the weight loss study, this is the percentage of people that improve in terms of their weight. So let's say the control group, this percentage of people, let me make it a better square, rectangle. If this percentage of people said that they actually improved, they didn't actually get the treatment. So keep that in mind. They don't know, the researchers don't know. But at the end of the study, this is all unblinded so they can see and put the people in the control group all together. And this percentage of people say we find that they've improved. What needs to happen to say the treatment was effective is that the treatment group has to do much better. And we're going to talk about what much better means to actually say the treatment is effective. Okay. We're going to talk about that towards the end of the course, but we need to see this. So this is called like a baseline. This creates a baseline to rule out that just because people are part of an experiment, they're going to do better. Okay. For whatever reason, mix of these two. These are very fascinating facts that people change their behavior. But the objective of the research is not to explore this, although there are studies on exploring placebo effects. The goal of these very expensive long-term trials are to look for a difference. Okay, so they focus on this and they don't get too much into where the heck this comes from and how big this is. Okay, so to have a statistically significant what's called a statistically significant effect in a experiment with human subjects, you need a control group to establish a baseline that you have to surpass. All right. Any questions? Okay, is it 7:30? Okay, let's take a break. Let's take a 10-minute break. So you guys can check your texts or whatever you do, get a drink. What am I doing? 10-minute break. And I'll see you back here. At 7:40. Well, it's not really 10 minutes, it's 8 minutes. 10:40, 10:41. Oops. Okay, I'm gonna start soon. Okay, I'm starting again. You can see the screen?
Yes.
Yeah.
So. Okay, I looked up the NRC to remember. It stands for NRC is the National Opinion Research Center, and it's located out of the University of Chicago. And they do contracts or they do work for a variety of clients, from Bill Gates, or Bill and Melinda Gates Foundation, to the US Census Bureau. So they work doing surveys for the government and others, and they work on an independent basis. And I'm pretty sure they get federal funding to do it, but it's supposed to be independent. Has to be of national importance or US importance, I guess. All right. All right, so no questions about this? All right, so in the notes, I have some comments to draw your attention to aspects of the videos that you may have overlooked, but I want to use the examples in the video. So I'm talking about experimental design and bias. You want to avoid, you want to do you want to do your best in experimentation to control against confounding factors like I described the rationale for the control groups in human subject experimentation. You need your control group so that other reasons are not the explanation for seeing an effect. Similarly, you don't want other reasons to explain your results. So what are some examples in the videos where or for survey or experimental design, what are some examples in the videos where a result was biased upward or biased downward? So I'm introducing the terms, even though they weren't in the videos, but that would describe some things that you saw where they were trying to measure something and the result was more, greater, or higher than was actually the case, or less, smaller, or lower than was actually the case. What are some examples of bias upward or bias downward?
They mentioned that like in the risk of cardiac arrest, the people may change their diet and exercise because doctors will be monitoring them constantly.
Right. So so if there's not a control group, the example was health outcomes, right? But that might not necessarily be bias upward unless, well, I guess the example they used was people, and the one I talked about was people would change their behavior and improve their outcomes, but it's bias because it's not the treatment or the intervention that was responsible for their health outcomes being higher or better. It was actually that they changed their behavior. So that's a bias upward. Any other examples of bias upward in surveys on the video? In the videos?
El de los cigarrillos cuenta que después de un periodo de años quienes fumaban eran 10 veces más inclinados a desarrollar cáncer.
But is that a bias? Is it incorrect?
Is it incorrect?
Because if it's bias, it means that it's systematically favoring certain outcomes and not realistic. That's what I want to calculate. That's what I want to capture in this, in the examples.
El de en el video de la encuesta, como que daban también a notar de que la forma en la que tú hacías la pregunta tenía que ver como con los resultados. Y entonces se dieron cuenta de que las personas daban resultados más exactos a lo que, pues, a lo que realísticamente hacían en vez de responder más que por responder.
Yes. So there were some examples, yeah, like in okay, they asked the questions on the survey. Remember, like okay, so if you think about the election, right? The election polls. To people with cars. It bias upward the support for the Republican candidate, right? That's an example. You remember, meanwhile, Roosevelt, who was the Democratic candidate, he won as for president. What was it? Presidential election poll. It was bias upward. Bias, it was the wrong answer. It was the wrong answer, but it tended upwards because they were only asking people with cars or telephones, and those people tended to have to be more wealthy, and they weren't like labor supporters. They were more, in favor of small government and lower taxes. And so they were showing support for the Republican candidate, and it distorted the results of the poll. That's a bias. So some other examples were the other surveys with Ann Lander's survey asking people questions. Okay, what about bias downward? Give me an example of artificially low numbers or incorrectly low numbers. So there was an Ann Lander survey. About sex after marriage. What did it show? If you remember. Only 18% of people responding only 18% of people that responded said they enjoyed it. Why is that bias down?
Por el estigma social.
Yes, people might not want to answer that question, and the people that are answering the question are unhappy or very emotional, and they're very emotional and reactive and they answer the question, they send in their comments that they don't enjoy it. And that distorts and puts the number that did enjoy it low. People who are happy and content, they're not complaining, they don't answer the survey. Okay, but people who are unhappy are answering the survey, and it biased downward the results. So these are just a couple examples from the videos, or you can think of other examples. So the idea is that when you hear in the news or you read, you want to read critically articles and think about how there could be bias in the way data collected. There's no perfect study. There's always bias, and you want to look at the analysts and how they've identified their biases and how the bias could affect their results. You don't need a perfect study to be able to publish it. You just need to be accountable for any bias that might have occurred. You have to be transparent and say there might be bias because we missed this, or the respondents were such and such. You do your best to try and control against bias, or improve your survey or your experiment to minimize the bias. But the most important thing is to identify it and talk about how that might have affected your results. All right. So you can still publish studies with bias in them. That's why Ann Landers managed to, that's not exactly a scientific publication of her findings, but people consuming that kind of information should be critical about how it was collected. And if it was scientific, she meant to provide a scientific reflection of her results. She would have to declare that, yeah, it's probably likely that this is relatively low for such and such reason, and not sensationalize her findings. Okay. Unfortunately, in the modern era, in our current contemporary world, sensational articles get published a lot. So you have to use your critical thinking to qualify what it is that you see. So there are all kinds of studies, right? So sometimes you'll hear eggs are good, and then you'll read about eggs are bad. How do you put all of that information together? Does anybody know, or do you just give up? Anybody have a thought about that? Did anybody have experienced that, what I'm saying? That you hear conflicting results and you don't know what to think? What are you supposed to do as a consumer of research? Nope.
Compare and contrast.
Okay, yeah. So there's a systematic way to compare and contrast. The systematic way is known as meta-analysis. Okay. Have you ever heard of that?
I don't think so.
You know what a literature review is?
Yeah.
So a literature review is where you can go into a database like Google Scholar or PubMed if you want to do medical research, and you put search terms in there and you collect relevant data to look at what is in the literature to date. A systematic literature review does it in a very specific way and tries to gather all relevant articles. And it does it in a systematic way. It comes up with a very thorough search strategy and identifies all the results from the search strategy. It defines inclusion and exclusion criteria to keep certain articles. And then it summarizes all the results in those articles. And if you conduct a meta-analysis, you actually combine all the results, the sample size, and the outcomes from all the studies and put them all into one. That will give you a meta-analysis result. So you use these two together to first get all the studies in a systematic way, defining exactly why you kept certain papers and you omitted others, combine all the results into one, which is not easy. I mean, studies have done things in different ways, but you're going to try and combine them. So you increase your sample size and you give a final statement of the results, all the results. So you're going to put in there, if it's about eggs being, improving your cholesterol or eggs making the cholesterol worse, you put all the studies. So one study could have had 3,000 participants. Another study could have had 2,000 participants. Now you have 5,000 participants and you put all their data together. And that is what a meta-analysis is. And it's a very, there's a whole science behind it. Meta-analysis is really critical. So if you ever want to know the truth, you want to get down to the truth of a topic, look for meta-analysis, look for systematic literature review, and look for studies that have done both to get the truth. Okay. So just looking at individual data points here and there is not enough. You want to look at the totality of research. All right. I'll just say, so meta-analysis can be done with experiments. One second. Let me see. Yeah. Yeah. So you could also do meta-analysis for observational studies, but it's a little more challenging. You want to standardize, from country to country or group to group. They might have done their studies slightly differently. So that could also rationalize why you leave certain studies out of your meta-analysis. You're leaving them out after an evaluation period, and you will include them until you justify why you left them out. And you would have to list them in your report if you did a systematic literature review. Okay. All right. So some key points about experimentation, I've listed them here. The idea is to intervene or treat a subject and measure how it or she or he responds. It could be a person, it could be an animal, it could be an object, like experimentation in industrial engineering on improving hinges or improving a method of creating through 3D printing some object. Anyway, so this arises more frequently in the physical or pure sciences than in the social sciences. So yeah, we are talking about business. Experiments are not as likely in managerial science, but you'll be surprised to learn in economics and in marketing, there's lots of experimental research. Insurance is a little bit harder, but there are studies in insurance as well, looking at behavior given different insurance packages or insurance opportunities. You have to actually conduct the experiment. If you don't and instead rely on information that looks good, you can run into problems. When the experiment is not pure, responses can be confounded or confused by overlooked variables that can play an important role. So it's really important to carry it out. Often we produce, when you try and get the kinks out of your experiment, you run a pilot first to see how it runs. So that means you run it on a few subjects to see if there's any things you didn't think of that you want to control for. That's pretty important. Maybe if you're doing an experiment on certain subject, let's say you're looking at Alzheimer's patients and you didn't think about certain things like how are they going to take their medication if they have memory problems. You're going to learn about that in the pilot, and then you're going to find ways to resolve that before you do the full-blown experiment. You don't want that to confound the results. And experimental design must be careful not to introduce bias. Okay, an example of an experiment in the video that's different from the above. Anybody want to comment on a different experiment in the video that we didn't mention before? What about the theoretical experiment to see if smoking causes cancer? And they talked about taking babies at birth and separating them and having the one group exposed to cigarette smoke and the other group protected from cigarette smoke. Like, it's a theoretical exercise. And you can't feasibly do it in an ethical way. It would never pass what's called ethics review. So that's just another example. We're just doing short form. In the annotated notes that I provide in the in Moodle, you'll get that you'll see what I wrote there. And don't worry too much about writing everything down that I say here perfectly. So I have that in the notes. Okay. What are the two key differences between designing surveys and designing experiments? The easy one that you know is what? In experiments, a treatment is imposed. In surveys or observational studies, there's no interference, right? Got to spell that right. What's another difference that you noticed?
experiments, you use the double blindness, so it doesn't interfere with the data.
Well, the double blind nature is for human subjects. Experiments are not just with human subjects, right? So that's not the one I'm interested in, but double blind is for human subjects, and double blind is the term to indicate that neither the participant or the subject nor the experimenter researchers know what treatment, whether the treatment was given or not. So they don't know if a person is in the control or the treatment group. That information is left to a third party who reserves that information and separates it with codes that have been assigned to the treatment, either if it's a vial or if it's a pill. So that's not the reason, but thank you for that. That's not the key difference. So this one is not exactly spelled out in the videos, but in an experiment on human subjects or on other subjects, when choosing, and we'll talk about that, when choosing or assigning the subjects to the different treatment groups or the treatment and control groups, all experimental units are assigned. So you identify the participants or subjects of an experiment and we assign them all. We label them and assign them all, either to treatment or to treatment 1, treatment 2, treatment 3, or if it's human subjects, to a control group. But in observational studies, you just take a sample, you label, and you just take a sample of the subjects. You don't take all of them. So I mentioned this one. I don't know that you'll see that in textbooks or anything, but it's really important to realize that in designing experiments, you identify your subjects and then you use them all, because in human experiments, it's hard to get volunteers. So you're going to use all of them. So I'm going to say that particularly. Which also kind of goes into the double blind here, but anyway, particularly for human subject experiments, all subjects are randomized to different treatment groups. Now, obviously, the subjects are a sample, but we like to use all of them, assigning them all. When it comes to, so we label them and assign them. In an experiment. In an observational study, we label and then choose a sample of our, we select a sample of the labeled items and we let the other ones go. We're going to talk more about that. I don't think we're going to get to it today, but I'm going to leave you guys to watch the videos that I prepared for you when we're done. We'll see how far we can get. Okay, any questions? I didn't finish my words here. Are labeled or numbered. No, that doesn't make sense what I just wrote. We label and then choose a sample. Yeah, I wrote it right. It says we. I thought it said are. In other words, we do not use all. All the subjects that were labeled or objects that were labeled. Okay. Ready for the next? Then again, you'll see this in the annotated notes. All right, so what about this topic here? What is a lurking variable? I'm using the example that was discussed in the video. What do you remember about this example?
Que básicamente ese ejemplo se utilizaba como para gente como que ejemplificar como que si correlación no es lo mismo que asociación, algo así es. Por ejemplo,
Exactly.
de que el día que más se vendieron helados fue un día en el que se produjeron más muertes por ahogamiento. Por lo tanto, que si el helado estaba causando estas muertes, cuando en verdad no, es que ese día la playa estaba más llena que de costumbre.
Exactly. Okay. So, very good. So, it's observed that ice cream sales are high when drownings are high, but it doesn't mean that ice cream sales cause people to drown. Or sorry, ice cream doesn't cause people to drown. This is not a causation. In fact, there's probably a lurking variable, something behind that is affecting both the ice cream sales and the drownings to go up. So temperature, if temperature goes up, ice cream sales will go up because people are thirsty, they want to be refreshed, and they'll maybe buy ice cream. Also, but that alone is not going to affect ice cream. What's happening is that temperature is attracting more people to the beach, and then it's really the beach population that increases the ice cream sales, more people, more ice cream, and then also because more people are on the beach, more people are drowning, okay? So this, you could see this is causal, temperature causing people, increasing the beach population. You could see the beach population increasing ice cream sales and beach population increasing drowning. So these are related. If we do not identify the rationale or the variable that's actually increasing ice cream sales and drownings, we would call the variable a lurking variable. But if we can actually put a label on it, like a name on it, we actually call that an explanatory variable. And that's some of the terminology I talk about there. And we could actually research that. We can actually measure, we could keep track of ice cream sales, we can keep track of drownings, we can keep track of temperature, we can keep track of beach population. We could test what's the relationship between one more person on the beach and what happens to ice cream sales, or one more person on the beach, what happens to drownings. Why would I care? maybe I'm a manager in charge of a certain beach, and I have to make sure there's a number of lifeguards on a beach, right? So I need to be aware of the beach population, or even easier, the temperature. Maybe the temperature influences the beach population. Let's test that. And then if the temperature is predicted to go up tomorrow or the next day or on the weekend, then I have to have more staff on the beach, more lifeguards on the beach. So you can use this information once you study, but you want to study these variables, see how they interact. And although ice cream sales might be easy to get and drownings might be easy to get, you can find, even though this one doesn't cause that one, that can still tell you or indicate to you if you need lifeguards, but probably temperature is easier to collect or observe and to help you make a prediction. So my point here is that once you have a name for them, you would call this the explanatory variable. And this would be your response variable. Where you want to study, these relationships. Until you've identified their name, you would call them lurking variables. Okay. So that word is reserved for things we can't really pin down. You can speculate, like in the example talking about factors that influence cancer or can impact cancer. The cigarette or the tobacco industry, cigarette manufacturers, would suggest that, wait a second, it's not necessarily cigarettes. There might be another variable. It might just be genetics, that some people both are more likely to smoke or smoke more because of certain genetics. And at the same time, those genetics predispose them to lung cancer. It might not have anything to do with the cigarettes. And they're not responsible, they don't have the means to figure out what that is, but they would suggest the lurking variable might be such and such. All right. Okay, then I got into sampling and surveys. In sampling the subjects, usually people are not treated with anything or otherwise interfered with. The subjects are not asked to do anything other than to respond to questions. Samples are observational or exploratory, where the data has been collected in a random fashion. Notice this whole unit is about collecting data and giving you a insight to how data is collected, how good data is collected, how bad data is collected, and then how it's done in terms of surveys and experiments, right? Because the next unit is going to be about what to do with the data. Samples should be, are observational or exploratory studies where the data has been collected in a random fashion, random, not haphazard. And that's discussed in the videos. Usually not everyone is in a sample. Sometimes a very large sample where everyone is included is conducted, and it's called a census. That's different. Large samples are often expensive and may even be inaccurate. So we might really want to get the homeless in the population in a census, but we're only going to do that every 10 years because otherwise it's very costly, or, less frequently than every year. We have to be concerned of people without phone numbers, and phone numbers aren't listed. How are we going to find those people? It's very expensive to try and do that, but there is an attempt, and I think it's in the law that this has to be done to actually ensure that representation in government is identified or accounted for by trying to count for everybody. Sampling arises more frequently in the social science, economics, managerial science, and sociology and psychology. than in the physical sciences. You must be doing this properly not to introduce bias. So examples of census in the video or survey in the video. Some examples are the census of the homeless. And then surveys in the video, again, the labor survey that they were collecting, employment and opinions, NORC surveys, National Opinion Research Center in Chicago surveys. All right. All right, so then I go through different types of experiments here, and I explain why we need a control group with the human subject. First, some terminology. The experimental units known as a subject is what or who is acted upon. The treatment are the experimental conditions applied to the unit. The response is the measurement of how the unit responded or reacted. The factors are known as the explanatory variables. The levels of the factors are different treatment corresponding to different levels or values of the factor. So I have my first experiment here. So you have to collect some volunteers with the goal of measuring the impact of consuming 1 ounce of alcohol. So get your individual subjects to consume 1 ounce of alcohol and measure the blood alcohol level after 1 hour. The experimental unit is the individual consuming the alcohol. The treatment is the ingestion of alcohol. The response is the blood alcohol level after 1 hour. The factor we're measuring is the impact of alcohol, and this is the level. Now, you can have a variety of levels depending on the percentage of alcohol content, so you'd have more levels here. So this is just a simple example to illustrate what these terms mean. What kind of experiments are good? The randomized comparative experiment works. This is discussed in the videos. And they work provided that they're constructed to observe the 3 R's of experimental design: representation, randomization, and replication. Representation is achieved through control. Randomization was discussed in the videos. It has to be done correctly. And then you have to have enough subjects to be able to see something. And what we're going to look for is statistical significance between the treatment group and the non-treatment group. Or the variety of treatments in a non-human experiment. Well, here's an example of why we need a control group. Imagine that I'm going to study the impact of, on patients suffering from pain of a stomach ulcer. We are going to apply a solution that's relatively cold through a pretty invasive or uncomfortable procedure that needs to be performed in a clinic. So the patients will come to the clinic first to get screened to be part of the experiment. They have to be referred by their doctor as having a gastric ulcer, stomach ulcer. And they're going to be screened, and then they're going to be asked to show up at a certain date and time to fill in a survey. So there's a survey that they have to complete, and it captures some demographic information and their relative measure of pain from the ulcer. Then they're going to be invited either that day or a subsequent day. A treatment will be applied. The treatment will involve freezing their throat, like so for an anesthetic. Then a tube is going to be put down their throat, and using ultrasound, the location of the ulcer will be determined, and the tube will release the treatment, or the treatment will be released through the tube to neutralize the acid produced at the site of the ulcer so that they feel less pain. They'll be asked to go into a recovery room for a time, and then their observation in a subsequent post-treatment survey will record how they feel, their relative sense of pain, discomfort. So in this experiment, the patient with gastric ulcer is our experimental unit. The treatment is the solution applied to the location of the ulcer to reduce the production of acid. The response is the self-reported level of pain. The factor is the solution applied, and the level of factor is the temperature of the solution, let's say. So I'm going to put something that's really, the treatment is going to be relatively cold to neutralize versus one that's just lukewarm water. In this experiment, all I'm doing is putting the solution, the actual cold treatment. So let's say the result of conducting this experiment demonstrated that people, majority of people feel better after the treatment. What's wrong with this design, this experimental design? What's missing? So the way I describe this is with human subjects. What's wrong with the study? This is not a good study because we're missing a control group, right? We have conducted this experiment. Regardless, everyone's getting the treatment. We don't know if the people getting the treatment might just feel good because someone's caring about their pain and helping them resolve the pain. They went through all the trouble to get there, take a day off work, to be there, to get this treatment. It better work because they've been suffering too long. Also, they're treated very nice by the staff, and they're given money for their parking. So they're having a pretty good experience. And at the end of the treatment, they're all around feeling good for a variety of reasons, and they feel less pain. They're distracted from their pain also. So maybe we should have a control group to control against them just feeling better for the reasons of being part of the study, the placebo effect, in other words. So in this study, we introduce a control group, and now what happens to the elements of the experiment? Still, the experimental unit is the patient with the ulcer. The treatment is the cold applied to the location of the ulcer to reduce the production of acid. The response is the self-reported level of pain. Everything is the same so far. Factor is the solution applied to the gastric ulcer. So all these are the same. What changes is the level of the factor. Okay, this is where you see the control come in. Either there's a cold temperature for the treatment group, or we enter a body temperature or lukewarm temperature for the control group. So they don't actually have a cold solution going to cut the acid. So in this experiment, let's say we find that there is no difference between the treatment and control group. They're both saying, you know, a considerable percentage of people say they feel better, but there's no difference. Okay, so there's no outstanding difference. So this would have, this would be an indication of no statistical significance. So if this is the treatment group, that's my symbol for treatment. And this is the control group. There's no real difference. Even this little slight difference makes it look like the treatment does worse. Okay. But let's say there's no statistical difference. It's just people feeling better because someone's helping them with their pain. It's just people hoping to get better that made them feel better. Placebo effect. Any questions so far? You guys have gotten quiet. Okay, we have like 10 more minutes or 15 more minutes. Let's use all the time we can, because now I want to talk about the third experiment, which is the physician health study. Remember the aspirin study, the physician health study. Actually, in reality, the aspirin study was conducted at the same time as the beta carotene, beta carotene study. So they identified 22,000 male physicians willing to participate in this study. So they took advantage and studied the impact of aspirin in reducing heart attacks and the impact of beta carotene in reducing cancer at the same time. So they took advantage. Now, it's not mentioned in the video, but I looked into this and found out that was a large study that followed physicians for a long time. I think it was almost 10 years to see the long-term effects. Now, my question to you is, why did they study 21,996 male physicians? You guys there?
Yeah.
Yeah. So why? Just throw some ideas out there. So this took place in the 80s. I don't know if that's relevant, but it's a while ago. Why did they study male physicians? Let's see. Let's make a list of reasons, possible reasons. One, so unfortunately, men die first. It still looks like that way, that they're at greater risk of heart attack and dying. So what does that mean in terms of our experiment? Well, we want to study an at-risk population that are more similar, okay? The more variation among our subjects, the more subjects we have to include in the experiment. So we want to make them more similar. So we're just going to study males. Also, males are at higher risk, so we're going to help resolve the more at-risk population. And also, we're going to be able to witness more heart attacks. So that's kind of the downside, but we're going to be able to observe more heart attacks. So again, we don't have to include so many subjects in our study. Okay, we're going to see the effect sooner than later if we were looking at women. So in the end, this translates into not needing we don't need as many subjects as if we included women in the study. Similarly, physicians. Why would we include physicians? This is a long-term study, and long-term studies are very valuable. However, there's a trade-off that you're going to lose people. They might die, which you want to record. You don't want to lose them. You don't want to lose touch with them. Physicians are all licensed professionals. They're registered, and you can find out where they live, where they are, what happened to them, much easier than if you just ask anybody to participate or any man to participate. So it's easier to follow them long term. What's another reason to use physicians? They have personal and professional interest in the results because they have to treat their patients. They want to know, they probably are more likely to comply and stay as part of the study because they have their careers, they have their patients, their practice, and they want to know the results of the study. And they understand the significance of this study. Any other things that you guys can think of that will impact the model or the structure of the study? Our goal is to be, so this is a discussion of representation and control. We identify male physicians because male physicians are going to be more alike than all males. So in other words, when we assign them to the different groups, we're more likely within the groups to have similar characteristics spread out over the group. So let me show you what I mean. So let's say we make our list, our labels. Let's say we have 21996 participants. So this I'm going to use, this is our N equals small n for sample size, right? And what we're going to do is label. So we have Dr. Lee, Dr. Adams, Dr. J, Dr. Bentley. Okay, so these are my doctors. What is the first label I put in terms of numbers? What's the label? What's the last label? What's the last label? Who's there? You guys there? What's the last label? What's the last number? You guys should know the last one. Isn't it 21,996? So what's the first label if that's the last one? The last one has 1, 2, 3, 4, 5 digits. So the first one has to have 5 digits. So what's the first one? Claudia, what's the first one?
I don't know.
But do you understand the last one is this one? So I have to number all of my doctors. So this is the last one. The rule is that all the labels have to have the same length. So the first one should be
00001.
very good. 0, 0, 0, 0, 1. And the second one, Claudia?
0002.
Excellent. Okay, so that's how it goes all the way down. 0, 0, 0, 0, 3, 0, 0, 0, 0, 4. Ba, 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 ba. Okay, so they all have to have the same label. Make a note, that's the rule. Same length of digits, so number of digits. Now, we're going to use a random digits generator or the tables like I showed you, and we're going to pick 5 digits at a time. And let's say the first number that comes is 0, 1, 2, 3, 4. So whoever 0, 1, 2, 3, 4 is goes into treatment 1. Treatment 1 is that the person's going to get both aspirin and beta carotene in this group. Okay. Now the next one we pick, let's say, turns out to be 0, 0, 0, 3, 5. That person's going to go to the second treatment group. And then the next one is going to be 20001. Let me get rid of that comma. And that's going to go to the third. And then 11111 will go to the fourth. And we keep going. How many doctors will be in each treatment group approximately? Divided by 4, what do you get?
1,499.
So it's about 5,000. How much? 100?
499.
So like, oops, 4,499 will go in each one. Okay. And so this is more than 5,000, almost 5,500 in each one. Completely random. This is a random process. And what we can expect is because we took so many subjects that this group will have just as many overweight doctors as they have average weight doctors. Sorry, let's say that again. This group will have just as many overweight doctors as this group has, and this group has. It will have just as many average income doctors as this one has, this one has, this one has, and this one has. It'll have just as many very rich doctors in percentage as this one and this one and this one. So we're hoping that there's going to be a similar appearance of the demographics that influence health in each group, that these are not so different. Okay, because doctors vary, the demographics of doctors vary, but they're more similar. Education is another influence, education, income, and lifestyle all influence your health, right? And it'll influence doctors' health. And so you want to be able to compare the treatment, aspirin here and beta carotene here, against aspirin and no beta carotene, just a placebo. You want to compare these groups where they're both taking aspirin against this group where they don't have aspirin, they have the placebo. And the way you're going to do that is you're going to combine these outcomes. You're going to count how many people, in the case of testing for aspirin, how many people in all, like out of 11,000 are going to or will have died after the end of the study. You're going to count the deaths due to heart attack. And you're going to compare them to this number, the number of deaths due to heart attack of either of these. So this 11,000. Then you're going to do the same thing with beta carotene, but you're going to go this way. So you're going to compare beta carotene in either, this 11,000 versus this 11,000. What percentage or what number of people died of cancer during the study? And by doing that, by separating, having large enough numbers so that the groups look similar enough, you can attribute any differences to the treatment, not to the composition of the doctors in each group. The more like the subjects are, the better you've controlled for confounding variables, and the more likely the results are reflecting the impact of the treatment. So what were the results of this study? On the one hand, 239 of the placebo group died of heart attacks, but 139 of the aspirin group had died of heart attacks. So there were more heart attacks here, and it was determined that this was statistically significantly less in the treatment group. So that was enough evidence to claim that aspirin reduces the incidence of heart attack. All right. When they looked at the results comparing those who had the beta carotene against those who didn't, they didn't find a significant difference in the groups. Okay, questions? Did you understand that example more than you did before? I hope so. So we are like on page, well, we're more than half through the notes because the last 5 pages are going to be a review exercise. So what I'm going to ask you to do is finish reading the notes, answering the questions alongside the videos. I will send you, I'm going to open up the Moodle tonight, and I'm going to ask you to watch the videos I indicate beyond a certain point so you can finish the notes yourself. And then this week, I want you to start looking at Unit 2. Okay. Unit 2 is going to be, how do we use the data? So I'm going to ask you to start reviewing the material in Unit 2, but only after you finish Unit 1. So spend your time looking at the review exercises, the quizzes, and get a really good grasp of this material before advancing to Unit 2. So next week, I'm going to focus on answering any outstanding questions you have about Unit 1, and I'm going to begin Unit 2, graphing and descriptive statistics. Any questions? I'll let you go. Oh yeah, you're not supposed to write in the chat because um you can't write it in the chat because I'm not going to see it. All right. Okay, so I'm going to say goodbye, goodbye for tonight and keep
Goodbye.
in
Have a
touch.
good night.
I hope
Bye,
that
good
helped
night.
you. And
Bye-bye.
good luck with
Bye,
the
good
week
night.
and keep me posted. Okay. Good night.
Good night.